welcome. Introduction to NSX Data Center with SMP, and this topic is going to be presented by Igor Parsadano. I'm sure I said that wrong, Igor, so you can correct me. He is one of our solution architects, and with that, I will hand it over to Igor.
Thanks, Jennifer. And it's Igor Parsadanov. I'm a solutions architect at SMP, and thank you for joining us today, this afternoon, for introduction to NSX Data Center. Just to give you set up a little agenda, we'll go over some slides to introduce NSX Data Center, talk about how virtualization will help us in a networking field, some use cases where NSX is useful. And then after the presentation, we'll jump into a hands-on demo using VMware's hands-on demo labs, and we'll do a quick walkthrough demo of NSX and some micro-segmentation that we can do there. So with that, we'll start talking about NSX, right? So this, I love this quote, hardware. That's the parts of the computer system that can be kicked. This quote was penned by Jeff Pessis. This is back in the early 1990s, and it's definitely still true, right? That's how we can define hardware. So there's been a lot of innovation in virtualization in the data center. Our three basic building blocks of data centers: the storage, the network, and the compute on which you run your applications, right? So we've seen a lot of innovation in the compute space first, right? Back more than 15 years ago, VMware came out with virtualization, ESX, right? Ability to virtualize our compute hardware and run many workloads on a piece of hardware, right? And storage has seen similar virtualization now with things like vSAN and hyperconverged infrastructure, where we're able to virtualize the storage, abstract it, and present it to our workloads, right? And with that, we get better efficiency. It's more agile. We can quickly stand up workloads. So we understood long ago the efficiency and the agility that virtualization could bring to the data center. On the networking side of things, we had virtualization. Some things got virtualized. We had things like VLANs, right? We virtualized LANs so that we can have more than one LAN on a switch. But much of it hasn't changed, right? We went from things like three-tier architecture to spine and leaf architecture, but very much of the network world still lives in the hardware, right? It's still hardware defined. It's controlled on the hardware. Progress my slides. Here we go. All right. So the lack of network virtualization is kind of holding us back, right? So it's very much hardware defined. It's complex, right? It can be complex. It can be rigid. And with that, we have manual processes, right, that can slow things down. These were some of the reasons why we virtualized servers, right, to be able to get away from the rigidity, to be able to get better efficiency. Also, security, right? We've been securing our networks around the perimeter, which is a good way of securing the networks, but it has its weaknesses, right? So the perimeter-centric model is having its weaknesses. There's holes in it, right? And so when that perimeter is breached, you have your vulnerabilities in the east to west data flows, right, that the perimeter doesn't address. And if you try to try to do that east-west segmentation, right, try to get it into the micro-segmentation using hardware, you start to run into cost issues because of the amount of firewalls, the amount of hardware you have to put out there, the CapEx that's involved with it, and also the OpEx that's required to run all those hardware firewalls to be able to micro-segment using hardware, it really doesn't scale. Another challenge is cloud networking, right? Public cloud solves some of the data center challenges, right? You don't have to deploy and configure and manage the physical hardware anymore, but it also introduces a number of new networking challenges, right? And that's multiple clouds. A survey, a VMware survey, said that 67% of customers will rely on multiple clouds, right? Whether they're their own in-house private clouds, whether the business is starting to use public clouds or is full out there using multiple public clouds. With that, each cloud has its own networking model and its own security constructs. So you get inconsistent tools and policies. And different skill sets are required, right, to run with these APIs. Automation teams interact with different infrastructures. So network virtualization solves these problems. It solves the data center networking problem by providing the operational model of a VM, but for the network. We can abstract the intelligence of the networking from the hardware and place it into software, just like we did with the VMs. This means we can start to create, delete, backup, restore networks, just like VMs. It solves this problem for the clouds, right, by providing a consistent networking and security policy across your different clouds, different locations. So for network virtualization, NSX is the product from VMware that delivers on the promise of network virtualization. The vision for NSX is not just to be the network and security platform for the software-defined data center, which it can do, it is, but also to power the the virtual cloud network wherever the network extends, whether it's local on-prem, in the private cloud, or into public cloud. So NSX delivers consistent networking and security across the entire enterprise network. So VMware has been doing networking in software for quite some time now. First started with the vSphere distributed switch back in 2009. In 2012, VMware acquired Nicira, and shortly after it launched the NSX product. And throughout that, the delivery of VMware's vision for networking, to the virtual cloud network. How does the VMware NSX Data Center deliver on the promise of network virtualization? So we can dig in a little bit on where it sits and how it works. The network virtualization starts with your existing network infrastructure, right? So nothing needs to change from the network perspective. It works on it, right? So many organizations have deployed Cisco Catalyst switches, whether they're the Catalyst 6500 that's been around forever, whether you're on the newer platform like Catalyst 9600, whether you're using Nexus or Cisco 9Ks and you've built out spine leaf infrastructure. The physical network can be anything, right? It could be running on HP or Dell. NSX gives you that choice and allows the network hardware to be from any vendor. NSX rides on top of it, and there's multiple ways to deploy it, whether you're looking at doing micro-segmentation with your existing VLANs, or whether you're looking to take it to NSX all the way and have the network run directly in the hypervisor, right? And most people are already doing network virtualization, right? So if you're running VMware, you are already doing part of it with the vSwitch that's built into there. So NSX takes that vSwitch concept to the next level. It virtualizes the network functions and runs them in the software. Now, it doesn't do it as a separate VM that run, in your infrastructure. This network virtualization is embedded into the hypervisor. In the cloud, VMware runs these network functions as a service, as a SaaS-based model, such as VMC on AWS and VMware Cloud Services. So it delivers these functions independent of the hardware or the platform you choose. The impact on host performance is very minimal, and it's incremental. Since the vSwitch already processes each packet, the functionality just builds up on that. And it's very distributed. So as you add hosts to your environment, you're adding network and security capacity. Each host that you add to your cluster adds additional 20 gigabits of firewalling capacity to your network. So conceptually, it's very similar to network virtualization, to server virtualization. Network virtualization functions equivalent of a network hypervisor. It reproduces the network functions, but in software, right in the hypervisor. The abstraction layer sits between the underlying network that you already have and the virtual networks that you create within NSX. So it's the operational model of the virtual machine, but just for the network. And this can, with NSX-T for data center, whether you're running virtual machines in VMware or you're running containers or a mixture, it can all play in this environment, and you can spin up their network resources in seconds. Now, with that, you also get microsegmentation. It comes part of it, right? So it's on by default. So these networks are secured and can be isolated from each other, right? So we'll get into that during our demo. So the key use cases for the NSX data center. Security is a huge one. Automation is another one. And multi-cloud networking. So with security and microsegmentation, the stateful firewall that's in NSX is embedded in the hypervisor. So the firewall is really down to each and every virtual machine, down to the VNIC of that virtual machine. And that's what's called microsegmentation, right? Is the segmentation down to the VNIC. So as I spoke earlier, right, the perimeter firewall model allows once it's not when it's not rather it's not if but when the attackers will breach that perimeter firewall. And when they breach that perimeter firewall, those attackers find a way to spread east to west, right? And that's because they know that there's in a typical data center there's very little security for the east to west traffic. So NSX reduces the risk and it minimizes that impact by using microsegmentation. So microsegmentation is very hard to do without some kind of network virtualization, right? It can be done with hardware, right? We talked about putting physical hardware firewall appliances, but to be able to keep up with the growth and the complexity, it would be just a CapEx and OpEx nightmare, right, to manage. Also, security in software down at that VNIC level means that the policy that you assign to the workloads moves with the workloads as the virtual machines move within the cluster, right? Or as they move from one private cloud to another or into the public cloud, that security policy that you assign moves with that workload. Also allows you to create DMZ anywhere type of infrastructure, so that you can really DMZ down to the workload, and you can deploy DMZs. Your whole environment, right? Your whole server environment could be a DMZ if you choose it to be that way. Automation, the other use case, right? So once the network runs in software, it becomes much easier to automate. You can have complete network topologies defined as a blueprint and rapidly deployed on demand. IT can begin to automate the network processes to deliver fast and consistent and secure provisioning of resources. developers, right, it can start using their tools and their APIs. And if your organization runs this way, they can start to spin up parallel development and test areas right next to the production, and spin them up and spin them down without having to put in a ticket to the network team to create those resources, right? So this could be completely automated by developers, increasing efficiency, increasing agility for the business. And also multi-tenancy. If you're in an environment that uses multi-tenancy, you can quickly spin up tenant networks within your environment, right, and provision them without having to do manual labor on creating these. And multi-cloud networking. Ability to replicate virtual machines from your primary to recovery site is only half the battle, right? Because applications are no longer just virtual machines or workloads, right? They are a network of virtual machines. You have your three-tier apps where there is web and middleware and database, right? And they're all in the network. They have policies on how they work together. So you can now virtualize that network and treat it as if it's a VM, right? So recovering an application to a secondary site usually requires the network to be recovered. And NSX does this in software, reducing the RTO and the cost of downtime. NSX also brings you the ability to start doing layer 2 over layer 3, pulling data centers as if they were a single location. Allows you to deploy apps anywhere and improve availability, and also increases the utilization of the underlying hardware. So NSX enables a big step forward for IT. It's not just about the technology. New world of IT requires collaboration between teams. NSX is a key enabler to help break down IT silos and foster collaboration. Now, to be clear, this is not about VMware admins taking over the network. We still need network engineers to design and be responsible for the networking in the new era of network virtualization. Their skills are extremely important and needed even in the virtualized networks. NSX gives them the tools to be more efficient and agile. Organizations are building cross-functional teams that operate infrastructure much more efficiently than before by using automation. Processes that were once manual can be automated, both reducing complexity, reducing the errors, the human errors that are involved with that, and ultimately creating a culture where IT becomes more agile and delivering greater value for the business. Right. So with that, that was my last slide. That covers the presentation material. We'll jump into our demonstration in just a minute. I'm going to stop sharing this and set that up. And while we're doing that, we'll see if there's any questions. I'm not sure, Jen, if we had any questions. So if you have any questions about this material so far, go ahead and shoot them over in the Q&A while I prepare the demo environment.
I don't see any in the Q&A at the moment, Igor.
Okay. Okay, and I'm going to share my screen here. All right, Jen, can you see my screen with the NSX-T main page?
Sure can. Yep, the
Excellent.
NSX-T overview.
Excellent. All right, so in this demo, And by the way, this is a demo from VMware. They have many hands-on demos that are available to learn more about the technology and get your hands into it and manipulating it. They're called hands-on labs. So if you Google VMware hands-on labs, there's many labs that come up. This one here is on NSX-T for data center. And we're going to take a look at the security functionality of NSX. We're going to take a look at the distributed firewall and ability to do DMZ anywhere type of architecture. So part of this demo, they've set up a 3-tier application that has a web server, an app server, and a DB server, and it's accessed by the client. I put it up on my screen here, just the quick communication between them. Some of the ports here aren't the typical ports, right? You don't usually see the app server talking to the DB over port 80, but that's just a lab environment, so we'll go with those port numbers. So at the beginning of the environment, it's NSX is installed. You have your virtual machines, you have your application running, and we can actually see, right? We can open up a new browser window, go over to the 3-tier app, choose Web 01, and we can see that the customer database is loading up, getting some results back. NSX is currently not defined with any firewall policies, and it's kind of configured in what's known as the blacklist model, meaning that it allows everything to flow unless you blacklist it. What we're going to do is actually we're going to go ahead and switch it from the blacklist model to the whitelist model, meaning that it's a zero trust environment where every specific flow is going to have to be allowed explicitly. And we're going to go and do that. So on the screen here, actually, before we get there, let me show you a little bit about the setup here. So in our inventory, we have a couple of groups set up. We have groups set up such as app servers, DB servers, web servers. Now, the way that these are defined is unlike in a typical firewall where you create a group and you associate IP addresses with a groups, right? This is actually done using tags. So we have our virtual machines that are tagged with certain functionality. And in this case, we can take a look at the web servers group. And we can take a look at the group definition. And the criteria for falling into the web servers group, it's a virtual machine tag equals web. So any virtual machine that is tagged with web will automatically fall into this. So as you spin up new web servers, you don't have to come into the web group and add IP addresses. You just, part of your provisioning process of the web server, you make sure that that web server is tagged with the web tag, and it will fall into this group. Any policies you define on the web servers will automatically apply to that workload. Also, as that workload moves or has its IP address changed, the policy will follow it because it follows the tag. And the firewall policy is really down to the VNIC level. So those are our groups that we have defined here and the tags that allow them to fall into those groups. Now, one group here that's a little bit different than the others is the main console group. The main console group is defined by IP address, the IP address here, and that's the IP address of the jump box that I'm on, right? So, so you can still do groupings and firewall policies by IP addresses if there is a need for it. I just wanted to point that main console group out. So let's go. So let's take a look. So the web app is still working. We should be able to ping our web server's pinging, and we will still be able to SSH into our web server. There it is. What we'll do first is we'll go in and switch our security policy from the blacklist model over to the whitelist model. So right up top here on the distributed firewall, it's currently in blacklist model. We'll go click that and switch it to the whitelist. Save. With this change, our web app should no longer work because we broke our communication. We've totally stopped all traffic from flowing at this point in time because there is no rules allowing anything. I should no longer be able to ping the web server, and my SSH is no longer working. So let's go and create some rules and see how easy it is to start micro-segmenting the data center network. First of all, let's create a rule in our infrastructure section that allows certain base services, right? So let's create a rule that allows things like ping, right? Ping is a thing that should be allowed mostly to any workload just because it's for troubleshooting purposes. Let's create an ICMP rule, and we'll say any source to any destination, we will allow ICMP. And we'll go ahead and publish that rule. At this point in time, we should see that ping should come back. We can ping things. Now our web app is still not working. Still going to be timing out. Let's also create a rule for our administrators to be able to perform administrative functions, such as be able to SSH to workloads, right? Currently I can't SSH to web servers. So in our infrastructure zone, let's go ahead and create another rule. We'll call this SSH. And we'll say sources, we'll specify the management console as the source that's going to be allowed to SSH. And let's create the service, or select the service rather, for SSH. Apply that. Publish it. But this time, I should be able to start SSHing into workloads. Yep, and SSH is back and working. So now let's go ahead and define our application policies. Let's make our application start working again because it's still pretty broken. Let's create a policy. We'll call that our 3-tier app policy. And within it, let's start making our rules. So let's review our rules here. So the client will be accessing the web server on port 443. So we'll create that. We'll call it client to web. Our sources are going to be any because that's our clients. For destinations, we'll select our web servers. And for services, we'll select HTTPS. Let's go ahead and continue and create our next rule. And our next rule is going to be from our web servers to our app servers. It looks like web to app on port 8443. So source, I'm going to create a new rule. I created a new policy by accident. We'll delete that. New rule. And this is going to be web to app. And our sources are going to be our web servers, right? And our web servers are going to be talking to our app servers. And they will be talking on 8443 as our flow diagram showed. There's TCP 8443. And let's clean up, let's delete this new policy that I created by accident. And let's create a new rule. And this rule is going to be for our app to our database. So our app servers located here are going to be talking to our databases here on port 80. App to DB. So our source, app servers. Our destination is going to be database. And this one is oddly talking on port 80. That's just HTTP. Go ahead and publish this. And if I did this right, this should work. And it does. All right. So we got our web app. Now, our web app is back to working. But not only that it's much more secure now, because we've now implemented micro segmentation for our 3-tier app. Our web server is only going to be allowed to make outbound calls to the app server. It's not going to be able to directly talk to the database. And our app server is going to be able to talk to our database, but it's not going to be directly reachable by our clients. So we've secured this application against east-west type of attacks. We created microsegmentation, and this is our DMZ anywhere type of solution here, where you can quickly segment applications right where they live now. We don't really care about their IP addresses, right? We're doing this segmentation using tags that are assigned to machines, and this scales very easily, right? So if you are here going to be building more of these 3-tiered applications, more web servers that you're adding to the farm, the policy is going to be automatically updated, right? There's no need to go in and change anything in the policy to add servers. It's going to add those automatically. And with that, this concludes the demo. Hopefully this was helpful, that you enjoyed it, and I'm hoping that with this, you are able to go and take this lab has more sections to it, right? Sections that allow you to discover things like the load balancing functionality, or layer 2 over layer 3 functionality. So I hope that you take the time to investigate the hands-on labs from VMware and check them out for yourself to learn more about NSX. And if you also have any questions about NSX, or if you think that NSX could be a good fit for your environment, I encourage you to contact us and see how we can help you with that.